Hello, everyone. Nice to meet you all. My name is Mykhailo. I'm going to be talking about voice bots. But before we start, I wanted to meet you a little bit. How many of you know what a voice bot is, especially after this beautiful presentation today? And how many of you tried to build a voice bot before? Okay. The third question was, how many of you know the difference between the cascade pipeline and the voice-to-voice pipeline? But once again, after this presentation, as many of you do. This gives me a feeling of how much you know about voice bots, so that's good. So a little bit about myself. I was a machine learning engineer, and then I started my own agency called Latency Labs 3 years ago. We shipped more than 40 projects since then. Most of those related to AI or heavily related to AI. And recently we pivoted into voice bots as well. So we do regular agents, but also we focus more on voice agents solutions. And I'm playing chess. So if you'd like to play with me, you can contact me on LinkedIn and we'll figure out how we can play online on chess.com or even live if that's what you're saying, because I'd love to. Wrong way. So when I was a kid, these folks were very close to me. I was watching this program all the time, this Mythbusters, for those who don't know. The concept is very simple. They picked some hypothesis. I don't know what's going to be if you blow up a fridge. Usually they've blown up something, in the typical case. And they made a hypothesis that it's going to blow beautifully or not. So in the end, they had the myth that they would either confirm, deny, or call it plausible. And this is going to be the concept of my presentation today. I'm going to be sharing with you 6 myths about voice bots, and I'm going to tell you whether they're confirmed, denied, or plausible. First of all, just for you to simply once again repeat what the voice bot is, in a really simplistic way, there are 2 ways to build the voice bots. One, on the right side, it's more like user audio comes in, some magic happens, and some audio comes out. We'll call that voice-to-voice models or speech-to-speech models. On the left side is what's called cascade pipeline. In the previous presentation, you saw even more details of that pipeline, but what you need to know is there are essentially 3 stages: speech-to-text, LLM, and text-to-speech. Those are like the major ones. So myth number 1. Voice calls cost 20 cents a minute. This myth comes from Vappy. Vappy is one of the most popular voice bot platforms these days. And they even post like cost of the bot. When you're building a bot there, they give you some impression of how much the bot costs. And in reality, a lot of our clients and just people building voice bots are hesitant about like realisticness of that number. So sometimes they build and launch and hope for the best. And it might happen that your billing would look something like that after more or less successful launch. I'm kidding. In reality, these are stats from product. I actually pulled it yesterday in one of the accounts we're managing for the clients. Realistically, it is around 20 cents per minute. But what you need to know is it largely depends on how long your voice bot conversations are. Let's say if you're providing service for healthcare clinic and you have 2-3 minutes where a person is just going to book an appointment, likely, yes, 20 cents per minute. If, let's say, you need to maintain a long conversation for some reason, I don't know. Let's say you're talking to an elderly person in an elderly care solution. In that case, you need to maintain like dozens of minutes. And then the longer conversation goes, the longer you have to hit compaction levels and the more tokens you have to consume. So in the end, your average cost of a phone call or a conversation through a bot can be bigger. So we'll call it plausible. That's how it works. So in this case, we neither confirm nor deny this myth. Callers behave like your test script. So I believe a lot of you here are developers, and you know that sometimes it works in our machine. And with voice bots, I saw how developers are testing voice bots. They're literally saying the same thing over and over again. it works magically. It's very good. And then they ship it to production and people saying something totally different. They use accents, they blabber, they mutter over their breath. Essentially, they're making it very hard for a voice bot. Voicebot completely fails. Yeah, typical developer makes a simple intuitive UI. Users manage to use it totally different way than they should be. And I have one particular example for you. This small American company called Taco Bell decided to employ AI to do orders for them in the driveway. And then one of the users decided to order 18,000 cups of water. Suddenly it became viral. So then every user tried to order 18,000 cups because people wanted to do a TikTok about it and go viral. And that was the result. What it teaches us here that users will try to break your software, especially if that software is trying to impose a human being, which in AI bot case is actually true. So beyond just having a clever prompt, you need to make it testing for like validity. Can you order, let's say, 18,000 cups of water or 260 McNuggets or whatever? You need to have some plausibility checks. Don't just trust what users are saying to you. And obviously, callers do not behave like a test script. You must now tell callers it's AI. In the past, we as developers, like, the overall goal of this is to try and replace a human in some scenarios when VoiceBot is imposing a human and talking to another human. You've probably heard about Turing tests before, and now it's pretty much impossible to pass it because according to laws in the United States and European Union, the bot has to disclose its bot, not only when it's asked, like right away. This is good and bad. Good because it obviously gives this understanding to the user who he or she talks to. It's bad because there is some sort of predisposure to AI, I don't know, trying to kid you, to take away all your money or something like that. Although in many cases, AI can be helpful, and this is sometimes the case with voice bots because they can replace humans for, let's say, in after-hour calls where humans have to go home and sleep. AI can talk instead of it. So you must now tell callers it's AI, it's confirmed, and if you'll see a company that uses AI bot and doesn't tell that to you after August 2nd in Europe, you can actually penalize them quite hard, and you can actually go to court with them using that previous product. Okay, myth number 4, the cascaded pipeline still beats speech-to-speech and voice-to-voice models. This is actually like a holy war in VoiceBot's domains because cascaded pipeline is what you saw with a lot of moving pieces. It has its pros and cons, but the major con of cascaded pipeline is being slow. All these components, they add up latency, and it's tremendously difficult to actually hit even 1 second latency on the VoiceBot in realistic production case. And opposite to that, voice-to-voice models are essentially models that are trained to mimic human conversation. They don't have a component, it just the audio comes, sometimes in a very good latency. So why not using it? Like, the speed is actually mostly there. Like some of the models on the left here, you would see that they are sub-second. So they have more natural posing. They can even laugh. There is compares humanness of how models are sounding, and some voice-to-voice models right now are 2-3 percentage points lower than human being. So you would not really they would not really differ too much. So why not using them? Because they're dumb. So there is a benchmark called Theta Voice these days. This is basically a benchmark used for voice models that compares how well they can do customer support tasks. And the best voice model can do relatively like 50-ish% of tasks. You can see how the others are like totally failing. So to give you some proximity, the voice bot with LLM in it would do something like this. So on the left side, you will see GPT 5.2 incorporated in the voice agent would figure out the problem in 80%, 85% of the time. But for those of you who work with GPT 5.2, it's going to be terribly slow. And if you're going to talk to it, it's going to sound very weird. But remember, that's going to be useful in the end of this presentation. And these are the typical problems that happening with voice-to-voice models. The result of this myth is cascaded pipeline still beats voice-to-voice. So if you have a production use case, you would still have to manage all these bits and pieces because that's like the only thing that works pretty much. LLM is the slowest part. So here are some comparison. Remember that cascade pipeline is text-to-speech, LLM, speech-to-text. So speech-to-text is relatively simple. It's actually one of the fastest parts of this pipeline. And there are a lot of good ones, especially on this left side, DeepGram. They even have great international models. They can speak Portuguese, they can recognize Portuguese, which is very difficult. Most of them also trained on English. So this is solved pretty much. Text-to-speech models, the ones that are producing the sound from the text, they're also pretty good. So you would see here humanness rating. So human is 100% humanness, of course. And then the other models are somewhat close, I would say. And if you want, I can actually share the link. If you contact me later, I can share the link to this playground. You would test yourself how human and AI compares. And trust me, you would not be 100% sure what it is this time or next time, whether it's an AI model or a human. But the LLM models, they are actually the slow ones. So this is the model we've been using the most in our pipelines. It's the GPT-OSS 20 billion parameters. It's still, the latency is still quite slow, so it's almost around a second. And also the delays can vary a lot. And other useful models in this domain, Gemini, Claude Sonnet is probably not usable, but at least it's smart. Gemini Flash is also quite useful, but what you would see here, the latencies are more than a second. And remember, in realistic conversation, you would want to have 400 milliseconds to 1 second latency. And if like one component of your voice bot takes 1 second, then what are you going to do? So the LLM is the slowest part. Speech-to-speech costs more. This is the last myth. Speech-to-speech costs more. At a certain point, these voice-to-voice or speech-to-speech models, they were actually costlier than cascade pipelines, which also made them a little bit worse. But now the cost is slowly decaying, and now you can use these latest Google models for even fraction of your cascade pipeline, which tells me that in 1 or 2 years, we'll probably all switch to voice-to-voice models. They should get better over time. And that's going to be reflected in my summary. But for now, the speech-to-speech cost is actually, oh, I think I got this way around. So speech-to-speech cost is actually cheaper than cascade pipeline. This should be confirmed. So bloopers. So what to do? When I was preparing this presentation, I found this beautiful thread on Reddit. You don't have to read it all. I'm going to read it for you, by the way. This Reddit message was 1 year ago. And what it says here, the critical challenges you'll face when developing Voicebot would be call quality connection, accent dialect handling, latency. So pretty much all the problems I've just mentioned in my presentation. 1 year ago, we pretty much had like almost the same problems with Voicebots, which might give an impression that the niche, the domain doesn't move much. But it does. It only does it with a fraction of speed. So if you want to build a voicebot for your business, for your company, here's what I suggest you to do. So first of all, figure out the price of conversation you can afford. Remember that it costs money. Ideally, if you can figure out the cost of a minute of a call you can do, the more calls take, the better your bot is, the more longer the call will be, but it's also going to be more pricier. And fun fact, we even had some voice bots where we had to fictionally try to steer conversation to end. So the bot was going to say, okay, let's try to trim it down. You maybe want to use the website or something because, yeah, we need to stop this call. Designed for the worst caller. We had customers talking with their speakers. We had customers talking with a horrible accent. We had very big noise. So when designing a voice bot, you should remember about that and you should account for that. And literally the biggest mistake you can do is just do a voice testing like this with a phone call sitting in a silent office. This is not going to help you at all. Figure out how to make a disclosure. So that's something we'll all be going to be experimenting a lot with, saying the right words to not scare the customer that this is AI and this is like potentially a Terminator or something. It should be more gentle and then less discouraging. Suffered latency, honestly, we've tried a lot of stuff, and in production use cases, especially in, let's say, Australia or yeah, Australia is the most prominent example. It's quite hard to find providers with good enough latency and fast enough latency, I would say. So at some point, you just have to suffer it. The idea behind is, if you want to build a voice bot, the voice bot must be solving the problem. If you're solving the problem really good, users will suffer the latency with you. It's not a big deal. If they can get, for example, if you need a dental appointment and you only speak English like I do, and in Portugal, not everybody speaks English, especially in dental care, you would talk to anybody. Come on, you would talk to a bot if it can get you an appointment. That's fantastic. So if your use case allows like great value to the customer, they will suffer latency with you as well. And ship cascaded pipelines for now, but follow the voice-to-voice pipelines closely, because my spider sense are telling me that in 1 or 2 years, they're going to get better and they will be the ones playing the game.